live up to that introduction, especially because I've got a cold right now. I met with Ricardo at lunch today, and he's excited. He's telling me about his passion for VR and how he's going to build this up. And I said, I've got a cold. Just don't make a big deal about it. I'll get up with my nasally voice and talk for a few minutes. So you guys will have to put up with me for just a bit. But before I get started, I'm just going to try to get this HDMI connection. I did actually put a little presentation together for you guys. So I wanted to tell you guys a little bit about our company, Faceshift, a little bit about history, what our product does. I'll give you a quick demo of it too, which is kind of exciting. And how this relates to VR, because we're doing a few things other than VR right now, so I'm sure there's going to be a few questions at the end. And I'm going to try to hit on those a few times as we go. I think the one thing I will say is having a cold is definitely a real-world experience. Unless there's someone in here working on a VR cold app, raise your hand and let me know. There's someone right here. One of the things that Ricardo and I did talk about at lunch today is that VR is sort of in the wild, wild west at the moment. I mean, it's fully open. You can do anything. And certainly there's a space for us in there as well. One of the things I like about VR in particular is we're building these immersive experiences. You're looking at incredible virtual worlds you're passing through, you're interacting with these, but they're not interacting back. And that in particular is something that Faceshift wants to help bring to the table, is that interactivity back into VR. We want to make VR social, and I'm going to show you a little bit about how we're going to do that. Our particular goal is to bring avatars to life. For storytelling, for interactivity, for communication experiences, in gaming and VR, across the board. We started in a research lab. So our company is Swiss-based, and we started in a research lab in Zurich, where our founders were computer vision scientists studying how the face moved. The research lab looks something like this. I've been told that's not the exact one, but something like that. Our now CEO was had built his own projected light scanner, huge device, filled up an entire lab, cost $50,000, broke every other day, but he was able to scan both live movement on faces and really study how they moved. And it was during this research phase that the original Kinect came out. In fact, some of you people in the crowd right here might have helped launch the Kinect or work on it. A revolutionary device that at the time there were depth cameras at the $10,000 to $15,000 range, but certainly nothing like a $200 camera for consumers. And 25 million of these launched into the world. And our CEO, as well as a number of different people across the globe, began hacking into them. What can we do with these? And he took the code he'd been using on his massive face scanning system that could never be commercialized and ported it to work with this little $200 consumer product. And lo and behold, it worked. Our founders then decided to actually launch a company to help tackle the animation market, in particular games, animated films, and visual effects. We launched our first product. It's called Faceshift Studio, and it uses depth scanners. So we're talking RGB color images and depth, and it produces very good facial tracking. It can work in real time, and you can do a number of things that are great for game studios. And I'll give you a demo of that really quick, just to give you an idea of what that looks like. So this is, by the way, this is something called a PrimeSense Carmine camera. PrimeSense was an Israeli company that built sort of the hardware guts of the original Kinect and licensed it to Microsoft. They went on to build this, which was a slightly newer version. And then they built a camera with the same capabilities of this, but was small enough to fit into a tablet. And before they could launch that, Apple swooped in and bought them out. So they're gone now, and I'm very much hoping we'll see tablets, maybe the next iPad with these sensors in them. In the meantime, I'll use one of their old sensors just to show you what it looks like. So this, what I'm about to demo to you, is the application that game studios, visual effects studios, animated film studios use today to create content. It certainly works in real time, but it's primarily oriented to people who want to record performances, save them out, put them on different characters, add them to their film and game later. And of course, I can't see my mouse as I'm doing this. There it is. So these depth cameras give you a color image, like you're seeing now. And in addition to that, they will give you... Oh, you're not seeing anything? Oh, okay. All right, that's like a PowerPoint feature, I think. Let me see if I can just close PowerPoint. So as I was saying, this is the application that is used currently at game studios, and I'll show you some of the game studios that use it in just a moment. We get out of it video data, and we also get this surface data as well. So that's me in real time. You can rotate it around, you can see my hand, so on and so forth. It's those two systems combined that we use as an input, the textured surface. So this is kind of essentially what we use as the input, and then what we need to do is turn that into something meaningful in the animation space. The way we do that is to train our system to understand the shape and texture of your face across a number of expressions. So I've got about 25 different expressions. I'll just show you a handful, and we'll do the cooking show version here in a second. So I'm going to scan my face. All right, so I just did 3 of the 25 scans, and what you see right now is a depth map of my face over on your right, and our generic tracking head on the left. The process that we do is we take that generic tracking head and we shrink wrap it to your data, so it becomes much more like your persona as it learns how your face moves across different expressions. I'll go ahead and you get the idea how that works. I'm going to load one that I did earlier. And once you do this training, the system actually runs live. So this is me, and if I go into our live system, I can actually show that version of me right off to the side running live. Just to give you a little idea, I can actually overlay that directly over my face. So this is actually quite nice. So you can see how well it's tracking different gestures, my lips, all in real time. The output of this, the final result of kind of what we're doing here are blend shapes. They're kind of expressions in real time of your face, exhibited in what looks like an equalizer. If there's any of you old enough to remember what an equalizer is. Each one of these different bars represents a different part of my face. And if I raise my eyebrows, you'll see some bars pop up right here. If I smile, you'll see some bars pop up over here. So each one of those is a 0 and 1 value for a different expression on my face. And we can take that data and drive virtual characters with it. So if I want to look at how I look as a hero character, for instance.
Well, hello. Did anyone here call for help?
And the moment you take charge of a virtual character, it gets real fun. I mean, you can take a different personality on as well. I could get in touch with my feminine side with this if I want. Which I'm a valley girl is my gosh. So yes, that's my feminine side. The goal with all of this is to drive a virtual character, and we can do it in real time. We can do it even better once we record stuff and save that out. And that's generally what we're doing. So the people using our system now in the gaming world are doing that with their own characters. Let me get PowerPoint going. Let's bring it down. And we've got a number of kind of big companies, actually some here in the area, doing really cool stuff with this at the moment. So we're really excited about what we're doing in the animation world in particular. But one of the things that's really exciting about these cameras is they are changing. In particular, when Apple brought PrimeSense a couple of years ago for $300 million, that ignited the development of this hardware. And I'll give you a brief glimpse of kind of what's happening. There's sort of two generations of hardware being developed. The first horizontal roll is the first generation. You've got the original Kinect, the device that now is owned by Apple, about that. Intel had a creative camera. And then an entirely new generation of either companies or hardware being built that's really exciting. So there's a next-gen Kinect, which is a fantastic device. But the things that I find really interesting are that the other companies are making these much, much smaller. So Apple now owns a device that's small enough to put into a tablet. Intel just launched the RealSense 3D camera. And actually, you can go to Best Buy right now and buy one of these now. The camera is 3 millimeters thick and maybe a centimeter high. And they're embedding them into the bezel of laptops. So you can buy one of those at the store right now. They just launched these. I bought a laptop on Amazon about 3 weeks ago. Now what this means to us, it's very exciting. For the first time ever, we're not limited to only allowing these big game companies and film companies access to this technology. Our goal has always been able to democratize this technology. So there's exciting things happening in the 3D camera space, and we are working currently on kind of future technologies, and we want to bring this out to the consumer space. So in particular, what we're working on right now is a teleconferencing application. So you'll be able to use one of these Intel, wow, I can hear myself so well now. You'll be able to use one of these Intel RealSense laptops or all-in-ones. That's a really loud, thanks. And be able to communicate over Skype or over FaceTime, over Uvu, Hangout, you name it, as an avatar. You'll be able to take on a different persona and communicate with anyone in the world. And that's really exciting to me. So we're pushing really hard on enabling that opportunity, and we're launching a product this summer to allow that to happen. And later on in the year, we'll launch an avatar store that goes with it, so people will be able to buy avatars to customize them, to do different things with them, and really have a unique persona that's just theirs. But those avatars take on some body movement from the inertial sensors and the HMD. And it's very compelling. You can have your buddy meet you in a virtual space, sit down right next to you. The audio is directional, so if he talks to you, it comes in this ear. You turn to him, it comes in both ears, and you can sit there and watch a game on virtual television. And it's a really compelling experience for people who are offset by a certain physical space in the world. But even further than that, you've got companies like High Fidelity. So the CEO of the startup High Fidelity was the former founder and CEO of Second Life, sort of that original virtual world. And they're actually using some of our tech as well as other people's tracking technology to create animated avatars and allow themselves to meet each other in virtual spaces. In fact, they have all of their board meetings in VR, and they meet each other and talk to each other. I'm going to give you a little brief glimpse of what this looks like. They just got a new round of funding, and they released a really cool little video that goes with it. Let's see if this goes. Okay. And luckily I was smart enough to copy this onto my desktop. So this is high fidelity. Oh, and I've got no sound for you. Sorry. And so, sorry about the lack of audio here. Let me actually just try this real quick because it's much more impressive than I can do. Okay, that's fine. So this is kind of what you visually see in their virtual world. You can meet with colleagues from any part of the planet, interact with them live, see their facial expressions, see their body movement, throw a baseball apparently, and it's a very compelling experience. There are other more serious applications for VR too that are interactive. One in particular that I find interesting is by a bunch of neuroscientists in Dallas. So they're particularly focused on autistic kids and soldiers coming back from war who've got PTSD, don't know how to interact with the world. In fact, all the people they're working on are all the subjects or patients they're working with are all the people who don't know how to interact with society at the moment. So they've created a virtual world. There's a real-life therapist with an avatar that's live. There's the real-life patient with an avatar that's live, who's given a task to enter into the virtual world and do everyday tasks. Go down to the local bakery and order a coffee and a muffin. And it gives this ex-soldier a chance to do common everyday things and learn how to readapt to society. Again, I'll do this without sound, but you'll get a little bit of an idea of what this looks like. So this is the virtual world that they've created. I can talk over him and act like I'm saying. So it allows people to re-experience what should be real life, to learn how to act socially, to show the types of expressions that should in social situations, and all while other people are interacting live back with them. So they're using Faceshift, obviously, to do a lot of this tracking technology and create a really engaging experience that actually is good for people. And then the last demo, and the first question I think I'm going to get here in just a second is, great, when can I get this with my Oculus, and how do I track faces when there's a big black box on half the face? I've heard this question a few times. This is, and what Ricardo said is, we're talking about the future, we're talking about the short term, and then we're talking about long term. That's something that's definitely on our list. We think we're the right people to bring social interaction to VR. So we've begun working on this space. I'll give you just a quick idea of what this looks like with a Rift. And what we're doing in this circumstance is we're using our existing tracking technology, and we're just avoiding the eye area. And it will give you a little bit of an idea of how that can work without the eye movement. And then as we continue on in this effort, we're looking at ways that we can track the face when it's blocked from the line of sight. So we've explored a few different avenues, and that's something we're definitely interested and capable of doing as soon as we can get to it. Put it that way. All right, thank you very much.